Hi there guys, today I want to show you a creation I made, and it's a homemade power supply. I was working on a university project where I have to make a H bridge, and I got this one controlled by a Arduino Pro Mini. Because our old H bridge, very old, seems to have given up. Unfortunately, I didn't have a variable power supply here at home, so I just hooked one up, and let's take a look at that. There we go, we got it right here. I got it mounted on a piece of wood like that. It's actually aluminium because it doubles as cooling. So what we got is actually, let's adjust the camera a bit. There we go. Here we go. If we take a look at this part first, this part right here, that's one of those buck boost converters with a 7-segment display that shows the voltage. It can be turned on and off on that button, and you can check the input and the output voltage on this button. Of course, it only has one output, and that's not satisfactory to me. So I upgraded it just a bit. I got the output into this PCB breadboard right here, and I'm actually separating the output into 3 lines below here. One is going up to this LM7805 chip, which actually is a MOSFET that turns everything into a 5-volt output on the last leg right here. So we got 5 volts to this amp meter I got right here, and I'm sending 5 volts to this output right here, or screw terminal, and the screw terminal continues through a wire down here, and I got a plug function where I can just stick wires directly into, and I got a screw terminal right here. So this is just for 5 volts, meaning this is what I use for my Arduinos, and it will only be 5 volts when I'm inputting anything above 6 volts, right? So I'm always safe with the Arduino, that's the point. Let's go back to the main part right here. Then I added these dip switches, and they are actually to turn these channels on and off separately. And even though I have the switches, I also added 2 LEDs with a very large resistor, that's a 1K resistor, just to keep the, well, let's say, like, if I'm not paying attention, it's nice to know that the power is on or off. So let me hook that up. I'm using a normal 220 power supply, and this is a it says 12 volt output. That's a bit strange. 1000 milliamps, that's perfect, that's 1 amp. But the problem here, it says 12 volts. I have measured it both with my this one, Elma multimeter. It's a pretty good piece of hardware. I also used one of my cheap multimeters, and I've tried this one. This one actually outputs 15 volts, so that's a bit strange. But nevertheless, for this, it's just fine. There we go. You can see it's powered on. Of course, there's no resistance or anything right now because we're not really using any power. So there you go. When I turn them on, the red light goes on for each channel, so I can determine them on and off individually. Let's see if we have a small screw. There we go. And right now you can see it says 6 volts, and I can turn it up and down as I please right here. I might actually add a small button to make this a bit more easy. Also, when I click this, I just turned the 7-segment display off, just like when you buy them on eBay. But when you click this, I actually measure the input, and you can see that's 14.8, 14.9, and sometimes 15 volts. So that's a bit strange, I think, on a 12 volt power supply. Of course, it's a very old power supply. It's at least, I think it's 10 years old. But that doesn't really matter. It should only put out 12 volts anyway. And this is, well, for this circuit it's fine because I can control the output voltage, right? But if I were to hook that up to something where the limit is 12 volts, I might run into some problems. So, luckily I can just turn this up now. Let's see how high we can go. There we go. Maximum 13.8. That's fine. That's fine. That's enough for me to power Arduino, maybe a LED chain or something like that. I usually always turn it down to around 6 volts because then I know that's a good starting area. If you want to know more about this homemade power supply, I can show you more, but there isn't really much more to show, except it's mounted on a piece of wood through a piece of aluminium that doubles as cooling. Of course, I insulated the back sides. I extended some of the tin through to the aluminium to enable the cooling. So it's the entire plate is actually working as a negative as well. You don't want that as a positive. So that's really it. I got a couple of capacitors to the LM7805 chip, and that's really just because you really need them. So on the high side I got a 100 microfarad. On the low side I got a 10. So I got a 10-100 ratio. That's fine. Thanks for watching. Comment, rate, subscribe. If you have any ideas for videos or something I might like to show you, you want to see more like that, right? Let me know in the description below, and I'll see you next time.